Hi everyone, today we're going to be doing reactions involving alcohols. Now, syllabus outcomes investigate the structural formula, properties and functional groups including primary, secondary and tertiary alcohols, write equations, state conditions and predict products to represent the reactions of alcohols including but not limited to combustion, dehydration, substitution with HX and oxidation. There's quite a bit there that we'll have to cover today, but again, just following along, trying to see what reagents we use, what the products are, and how it affects the functional group. So a bit of revision, alkanes undergo substitution reactions with halogens and UV light, so it replaces one of the hydrogens with a halogen. Alkenes, alkynes undergo addition reactions where we start with a double or a triple bond and we add something across it. So when we add water across a double bond, it gives an alcohol. When we react it with halogens, we get a di-substituted alkane. So we get, like, for example, two bromines adding at the 1,2 position or something like that. Reaction with hydrogen gives alkanes, so it just replaces that double bond with hydrogens. And reaction with hydrogen halide gives a mono-substituted alkanes. Now remember, with the reactions with water and the reaction with hydrogen halides, the hydrogen goes to the one that already has more hydrogen. Now, reactions involving alcohols. Alcohols contain an OH group, which is highly polar, so it's a good site for reactivity. And this region of partial charge allows them to react with other molecules. Now, however, the type of alcohol will determine how the molecule can react. So we have to do the difference between primary, secondary, and tertiary alcohols. So there are three types of alcohols. Primary alcohols are ones that attach to a carbon with 0 to 1 other carbons attached to it. So something like methanol. So on the left there's methanol. Notice how that OH is connected to one carbon, and that carbon itself has 3 hydrogens on it. So it's primary. So that has 0 other carbons attached. The example on the right, which is propan-1-ol, we have a look at the carbon that the hydroxide is attached to, and that carbon itself is attached to one other carbon, so it is primary. So it's the carbon that the OH is attached to is itself attached to one carbon and 2 hydrogens. Now, secondary. Secondary alcohols are attached to a carbon with 2 other carbons attached to it. So on the left there we have propan-2-ol. So if we have a look at the carbon that the OH is attached to, it's got 2 carbons coming off it, so it's secondary. Same with the one on the right, it's butan-2-ol. The carbon that the hydroxide is attached to itself to 2 carbons, so it's secondary. And tertiary alcohols are attached to a carbon with 3 other carbons attached. So if we have a look at the OH is connected to a carbon, that carbon is connected to 3 carbons. Yes, that's a tertiary. So on the left-hand side there, we have 2-methyl-propan-2-ol. On the right there, we have 2-methyl-butan-2-ol. Now, some of the reactions that we can do with alcohols. Dehydration reactions. So this is the opposite of a hydration. We're taking water out of it. The water molecule is removed and a double bond is left behind. It's accomplished using aluminium oxide as a catalyst or using concentrated sulfuric acid. So let's have a look at some examples. So here, propane-2-ol is reacted with concentrated H2SO4, and that produces prop-1-ene. Okay. Remember, we can name it either way. The double bond can also go either way. So it can go to the left or it can go to the right. It doesn't matter. In this case, it produces both the same molecules. Here, on the other hand, we have butane-2-ol, and it reacts with concentrated H2SO4 to form the alkene. Now, there's 2 different ways that the alkene can form. It can form to the left or to the right of that carbon, which means we get 2 different possible products. So we get but-2-ene or but-1-ene. So they're both of our products that we can have. So we need to remember that both products can form, and I don't think there's a particular tendency to go either way. Now, substitution reactions with alcohols, they can be substituted for chlorines. It involves something we call Lucas reagent. Okay, now this is an important one because we also use it in Module 8 for chemical tests. But Lucas reagent reacts with concentrated hydrochloric acid and zinc chloride. And basically it takes off an OH, puts a Cl on instead. Now, different alcohols react differently to Lucas's reagent. Tertiary alcohols react pretty much immediately. They're very quick. So as soon as you put in hydrochloric acid and zinc chloride into a container containing a tertiary alcohol, you'll see it starts to go cloudy, and that's the chloroalkane forming. Secondary alcohols, it takes about 5 minutes for that cloudiness to start to form. Primary alcohols do not react at room temperature with Lucas's reagent, but will react eventually if they're heated. Okay, so what we can do is when we're trying to figure out the structure of a compound, we can use Lucas's reagent to go, okay, well, that reacted immediately. That must be the tertiary alcohol version. Or it took 5 minutes to react, so that must be the secondary alcohol. Here's some examples. So again, propane 2-ol reacts with hydrochloric acid and zinc chloride to produce 2-chloropropane. 2-methyl 2-methyl propane 2-ol reacts with concentrated HCl and zinc chloride to produce 2-chloro 2-methyl propane. And that one, because it's tertiary, would happen almost immediately. Lastly, we have hexane 1-ol reacting with Lucas's reagent. And this one itself gives no reaction. Okay. But if we were to add heat, then it would react. Now, oxidation reactions. Oxidation and reduction reactions can happen in organic molecules, but it's slightly different because typically we talk about redox in ionic compounds, okay? But this is in a covalent compound, so it's a little bit differently. They don't really involve direct loss or gain of electrons. It involves like partial loss, and we're not actually going to look at reduction numbers or anything like, sorry, oxidation numbers or anything like that. We're just going to use this bit of a cheat. So when an organic molecule is oxidized, the number of bonds to oxygen increases. So that's how we can think about it for organic stuff. So oxidation reaction that can occur depends on the type of alcohol. Primary alcohols can be oxidized to an alcohol or a carboxylic acid, depending on the reagents used. Secondary alcohols can be oxidized to a ketone, and tertiary alcohols cannot be oxidized due to the maximum number of bonds already being present. Okay, so tertiary alcohol already has 3 other bonds, and so we can't increase the number of bonds to oxygen because it's already full. Okay. Now, oxidation reagents. So these are the things you have to remember. So the most common oxidation reagents used are alkaline potassium permanganate or acidified potassium dichromate. So KMnO4 or K2Cr2O7. Reactions will produce aldehydes from primary alcohols are very specialist and include PCC and PDC. Now we don't come across them that often, but they do exist and you have to remember them. So here's some examples. So firstly, we start off with propane 2-ol. We oxidize it with KMnO4. It oxidizes to the ketone. Okay, that's as far as it can go. With ethanol, if we stick that in KMnO4, we get acetic acid, so ethanoic acid. So it goes from the alcohol to the acid. Same with ethanol in potassium dichromate, it goes straight to the ethanoic acid. 2-methylpropane-2-ol, that's a tertiary alcohol. If we stick that in with K2Cr2O7, nothing happens because it's tertiary. We can't actually add any bonds there because that carbon's already filled with oxygens and carbons. There's no hydrogen to get rid of. We have propanol, so propane-1-ol with PCC. That will stop at the aldehyde. Okay, so it won't go all the way to a carboxylic acid, but it stops at the aldehyde. Now, combustion. This is another reaction that alcohols can undergo. You can light methanol, ethanol, propanol all on fire. Requires oxygen, produces carbon dioxide and water. And again, because we've done it a million times, I'm not going to do any examples. But again, if you're having issues, come see me. I'll show you the algorithm we can use to balance these equations. So in summary, alcohols can be primary, secondary, or tertiary, and this affects their reactivity. Oxidation reactions increase the number of oxygen bonds in a molecule, typically around where other oxygen is already present. Primary alcohols can be oxidized to aldehydes or acids, with PCC and PDC giving us the aldehyde, or potassium permanganate or potassium dichromate giving us the acid. Secondary alcohols can be oxidized to ketones, again using KMNO4 or K2Cr2O7. And tertiary alcohols cannot be oxidized, again, because there's enough bond, there's already the right amount of bonds there, we can't add any more. And that's all for today, thank you.